Hi guys, Dennis here, and welcome to my series on iOS development. In this video, we're going to review several common conversion methods that you'll be using a lot in the apps you'll build. We'll review converting strings to ints, strings to NSInteger, strings to NSNumber, and converting those back to strings for display in a user interface. We'll also review data types and what they're commonly used for, and string format specifiers that you'll be using throughout the development process. So without further ado, let's get started. So before we get into coding our conversions, I thought a quick review of string format specifiers would be helpful. And the first one here you're probably intimately familiar with. That's the %@ sign, and that's used for Objective-C objects, and that primarily includes NSNumber or strings. Second one here, %D, is for signed 32-bit integers. Then we have the %U for unsigned 32-bit integers. And in case you've forgotten, a signed integer holds both positive and negative values, whereas an unsigned integer holds only positive values. And FYI, if you don't declare your integers as either signed or unsigned, then they default to being signed. And the last one here, the %F, is for 64-bit floating point numbers. These are your decimal numbers or your irrational numbers. And if you ever forget any of these, or if you need something a little bit more advanced, you can go up and do a search on Google for string format specifiers. So let's do that now. So here we have Google opened up, and let's do a search on string format specifiers and see what we get. And this first one here, this is perfect because this is from Apple. This is the String Programming Guide, String Format Specifier. So let's take a look at that. And here we have a nice chart. And some of the ones that we've just covered, such as the %@, there's that guy, and the %D. And we have the %F for a floating bit number. And we also have some that are more specialized. Ones that are printed in scientific notation using a lowercase e, or here's one for an uppercase e, and some others down here on the lower end of the chart that might be useful for you. So if you ever need to get something a little bit more sophisticated, this is where you go to look. Okay, let's go ahead and open up Xcode, and we're going to create a new project. And this time we're going to do things a little bit differently. We're going to select under OS X application and then select the command line tool and click next. And the reason why we're going with this is we can show everything that we need to show without using a user interface. So let's call our project conversions, and we can click next and create. And we have our project. So we'll jump into the main file. And off the bat, we can go ahead and delete everything between the two main parentheses. We won't be needing any of that. And let's give ourselves some room while we're at it. Like so. So let's continue on with our review in code. And we're going to start off by creating two integer variables and assigning them a value. So int A, and we'll assign that guy a value of 5. And int B, we'll assign this a value of 6. Okay, now we're going to create 4 operations performed in 4 NSLog statements, and to spare you the pain of watching me type this in, I'm just going to paste it in. And there are 4 operations: addition, subtraction, multiplication, and division. Let's close out our utility panel here. We won't be needing that. Okay, so let's build and run. Take a look at what we have so far. And let me enlarge this debug window here so we can see. Okay, so our integers are 5 and 6. So 5 plus 6 equals 11. That's correct. 5 minus 6 equals -1. We are using integers, and they are signs, so they're both positive and negative, so that's correct. 5 times 6 does equal 30, but 5 divided by 6 does not equal 0. So what's the problem here? Well, obviously we're doing division, and we come up with a decimal, so that's just not going to work. In order to get the correct value, we need to change these to floats. So let's do that now. change that to a float, and we'll change the next one to a float. And we also have to make some adjustments to our log statements. We need to change the specifiers to F to represent a float. And this will get rid of this compiler warnings that we're getting here. Okay, let's go ahead and run again. And let me stretch this out a little bit more. And notice we have the same answers, and in addition we have our decimal here. But one thing to keep in mind is that it defaults to 6 digits past or to the right of the decimal point. And that's something that's inherited from Objective-C, so this is normal. So there are many cases when we don't want to see all those decimal places. Maybe we want more, maybe we want less. So what we do is use format modifiers to handle that. So let's experiment with that a little bit. So let's say we only want 2 digits to the right of the decimal point. Well, we need to add a 0.2 right before the F, and we'll do that for all these guys. 0.2 and 0.2, and we'll run it again. Now we have 2 digits to the right of the decimal point, and this looks a little bit neater. And obviously 0.2 would be ideal for showing values such as currencies. So also there may be times when we'll want more than the 6-digit default it gives us, so we can do that as well. Let's use 0.8 for example. So we'll change that to 0.8 on all these statements and run it again. And now it's carried out, our calculations are carried out to 8 digits to the right of the decimal point. However, there is something that you need to be aware of, and it's called a floating point rounding error. And we're going to go into that in a little bit more detail in a few minutes here. But just hold on to that notion that there is something that you have to be aware of here. Okay, so I think that's enough for our review now. So let's get into some conversions. And the first one that we're going to tackle is NSString to integer. And you're going to run into this one quite a bit. So let's imagine, if you will, that we have a user interface with 2 text boxes. And we've asked the user to enter an integer into each box, which we would then perform a calculation against. And those values entered into the text boxes will be assigned to strings, obviously. So in order to perform calculations, we need to convert the string values to integers. So let's do that now. Okay, so let's start off with a clean work area so we can go ahead and delete everything that we did in our review, like so. So first we need to create a couple of strings that represent what we receive from our text boxes. So let's create 2 strings. There's one. We'll just call this first string. And that's going to be assigned a value of, let's say, 5. And then we need one more. And we'll make this second string, and we'll assign that a value of 4. Like so. So obviously we can't perform math on strings, so we need to convert these string values to integer values. And to do that, we need to first create a couple of temporary variables that we'll use to hold our converted values. So let's create 2 temps, and we'll make this int a, and then we use a bracket, and then we use the first string, and we call the int value. Not the integer value, that's reserved for NSInteger, but the int value, which is specialized for integers only. Even though both of them will work, let's stick with the correct one though. And then int b, and that equals second string int value. And CodeSense knows what we want because CodeSense is pretty smart. Okay. And now we'll write a log statement to display the result of a simple calculation. So let's do an NSLog, and let's just write, what should we write? First string plus second string equals, and now we need a %. So we're using integers, so our format specifier will be a d. And then we need an argument, and our argument will just be a plus b. Like so. Let's build and run, see what we got. And first string plus second string, oh, got an I in there, I shouldn't. Let's run that again. That looks a little bit better. First string plus second string equals 9. Okay, so this looks good, but many times we don't really know what type of number the user is going to enter. It may be an integer, or it may be a fractional number. So the best way to address that is to make our data type a float instead of an int. And that way it'll manage either type. So let's change our input string to be a decimal number first. So we'll go up here to 5, and we'll make that 5.12. And we'll do the same thing with our other string, 4.12. Now we have to make a couple of changes, and the first one is we need to change ints to floats. Let's do that now. And then we need to change the integer value to, I bet you know what I'm going to do, it's going to be a float value. Now we need to do the same thing with the second one. Change that to float, and then call float value instead of integer value. We need to do one last change, and that's our format specifier. Currently it's set to an integer. We want to change that to F. Now we can build and run. And now we have first string plus second string equals 9.24000. Remember I said it carries out to 6 digits past to the right of the decimal point when you're working with floating point arithmetic. Now I mentioned this before, there are errors associated with floating point arithmetic, and let's go ahead and go into that now. And like I said, there's some idiosyncrasies on how the compiler deals with and displays large numbers that you need to be aware of. You probably won't run into them, but it's good to be aware of them. For example, watch what happens if I expand our two numbers to 6 decimal places. And remember I said 6 is the default, so let's just use 5.12345 here, and we'll go ahead and expand the second one as well. 4.12345 Okay, so let's go ahead and run that. And then we get an answer of 9.246912, and the compiler carries it out 6 digits. And that's the correct answer, but watch what happens if I change my modifier to 7 digits. So let's go up here and add one more digit here. We'll do 7, and we'll make this 7 here. And I'm going to need to change my modifier to 7 digits so it shows all digits. So we'll do a 0.7, and let's run it again. And now we get 9.2469130. Now, is this answer correct? No, actually it's not. The correct answer is 9.2469134. And if you don't believe me, go ahead, take out your calculator and check it. Now, this is an error associated with computer floating point arithmetic known as floating point rounding error. So the bottom line is know that that error exists and just be cognizant of it. When you're working with something that's greater than 6 decimal places, you have the chance of running into this particular error. So now that we have our calculations, we need to convert our answers back to a string so that we can display it in our user interface. So we'll do that now. We'll need another NS string and another variable to hold our answer. First, let's go ahead and we'll comment out our previous log statement because we won't need that guy. Then we'll create another integer to hold the results of a calculation, and actually we need to create another float, not an integer. So let's do a float, and we'll just make this C, and C is going to be equal to A plus B, like so. Now we need to create another string so that we can then assign its value to our text box, and remember we're imagining that we had a text box to display our results. So this is going to be an NS string, and we'll call the string answer, and now we use a bracket and then NS string, and then we call the method string with format, like so. And our format is going to be an @ %, and we use the %f because our modifier needs to be a float. Alright, and then our argument, of course, is going to be C. So what we've assigned the value of C to the string now. So the last thing we need to do is display it, and we'll just use a log statement like we did before to display our answer. So NSLog, and we'll just put @ sign, and then my answer is, and then we need a percent float, I'm sorry, a percent @ sign because we're displaying a string value, and then answer, like so. Now we can build and run, and my answer is 9.246913, and maybe we want to do a little specifier. Let's go back to our string and let's change that to 0.2 and then run it again. And now we've said my answer is 9.25. So if we want to change or add a format modifier, we need to do that when we're converting it to the string, like so. So that wraps it up for string to integer and integer back to NS string, so we're ready to move on to the next topic. And our last topic is going to be NSNumber, and as you probably already know, NSNumber manages both integers and decimal numbers. So once again, we can delete everything except for our two strings, and we want to convert those two strings to NSNumber. So to do so, we need to first create an instance of NSNumber formatter, and be sure that you use the NSNumber formatter and not just the NS formatter. So let's go ahead and create that. And we want this guy, the number formatter, not just the formatter. And we'll just call this formatter. And then we need a double bracket, and that's NSNumber formatter. And then we got to do an alloc and an init. Okay, so we have that initialized. Now we need to set the format style of our formatter, and we do that by using formatter, and then we set number style. And then when you want to use, you have two choices here, and we're going to use the NSNumber formatter decimal style. And as I said, you have two choices. You have the currency style and the decimal style, and we're going to use the decimal style, like so. Okay, so now we need to convert our strings to a new NSNumber. So let's just create an NSNumber, like so, and we'll call this first number. And that is equal to formatter, and then we want to call number from string, like so. And our string obviously is going to be this guy up here. We'll use the first one first, so that'll be first string. Now we need to do this one more time for our second string, NSNumber, and this will be, we'll just call this a second number, equals formatter, number from string, and this time we'll just, our argument will be our second string. So now we can write a log statement to print these values out. So we'll just do a log, and I'll just print one of them out here, and I'll just say my first, I should say first NS number is, and now we need a percent, and this is an object, so we'll use the percent at, close it with quotes, and our argument will be the NS number right here that we just created. In this case, we'll just use the first example, first number, like so. So let's go ahead and build and run, see what we have. And let's take a look at what our warning is here first. Oh, our warning is saying that we have an unused variable here. Let's check that out. Yes, unused variable, because we didn't do anything with the second number, but that's okay. We'll just ignore that for right now. So my first, oh, and I spelled first wrong. Let's go ahead and fix that. And we'll run it again. So my first NS number is 5.1234, etc., etc., etc. So what do we really have here? Just another object. We can't perform calculations to it, so what good is it? Well, what we can do with NSNumber that we're not able to do with ints or NSIntegers is that since this is an object, we can add them to an array. So let's take a look at using that in an array. So let's close our debug window, and we're not going to need this log statement, so we can go ahead and get rid of that guy. So let's create an array, and we'll just use NSArray, and we'll call this my array. And to build this, we're going to call the array with objects, so we do an NSArray and then array with objects, and our first object will be our first number, and our second object will be our second number. There's our two numbers, or our two objects in our array, and now we'll just use a log statement to display those. And we'll just call this, let's see, we need a percent and an @ because we're displaying objects, and this we'll just call my array, like so. Okay, let's go ahead and run it, and it should display our two array elements, which it does, 5.123, etc., and 4.123. So that's the advantage of using NSNumber, is that we can incorporate that into an array if we need so. Okay, we still need to convert our NSNumber back to a string so that we can display it in our user interface. And we'll take our first NSNumber for an example here. So let's create a new string, NSString, and we'll just call this my new string, like so. And to get that converted, we take our first number and we just call string value. So first number, string value, like so. And now we can do a new log statement. My string value equals to, and then we'll do a percent @ equals to, and then we'll just use my new string, like so. Let's run it for the last time. So my string value equals 5.1234, etc., etc., etc. So that pretty much finishes NSNumber. So our last topic is NSInteger, which I think is a hotly debated subject on Stack Overflow, when and how to use them. So according to Apple's documentation, NSInteger is used to describe an integer, of course. Its type definition is that of a long NSInteger. So when building 32-bit applications, NSInteger is a 32-bit integer, and a 64-bit application treats NSInteger as a 64-bit application. And I might add that NSInteger is a signed version and NSUinteger is an unsigned version. So here's my takeaway from all that I've just read you. If you don't know which platform will be running your application, either 32 or 64-bit, then perhaps the best approach would be to use NSInteger instead of plain old ints in your application. That way you're covered. Okay, so NSIntegers are virtually the same thing as plain old integers, so you can perform calculations with them. So let's take a look at how they can be used. And we'll close our debugger window. And let's get rid of all this code that we've used previously, excluding our string statements, because we're going to still use those guys. Okay, so since we're using an NSInteger, we have to be working with integers, obviously. So let's take this down to 5 and 4. We'll make that change right here. Okay, so first thing we need to do is to create our NSIntegers, and we do that basically the same way we created our ints from strings. But the thing that you'll need to watch out for is that you don't use a pointer, since it's not an object. So let's create an NSInteger, and we'll call this first guy A. And then we'll use basically the same method as we did for our ints here. We'll use first string, and we'll call integer value. And remember, before we used int value for regular ints, but this time we're going to use integer values. And we'll do that one more time for B, and this time it'll be second string, and once again integer value, like so. Now, as I mentioned before, you can work with NSIntegers the same way you would with ints, so we can construct a simple calculation. Let's do NSInteger, and we'll make this guy C, and C is going to be equal to A times B as an example. All right, now comes the rub. You would expect that we could write a log statement like the following: NSlog, and we just do A times B equals %D and close parentheses, and our argument would be C. But we're going to get a compiler warning here. Let's take a look at see what it is here. It says values of type NSInteger should not be used as format arguments. And it also goes on to say add an explicit cast to long instead. So it does give us a fix here. We can double click that, and as you can see, it added a cast to long. Okay, so now we can do an NSlog, or actually we've already completed that. We can go ahead and write it now, and now it says A times B equals 20, which is correct. Okay, so now that we have our answer that's an NSInteger, we need to convert it back to a string value so that we can display it in our imaginary text box. So once again, let me close our debugger, you'd think that we do basically the same thing. We need to create a string, and we'll call the string answer, and then we do with the bracket NSString, and then we'd use the string with format. Oops, NSString didn't come up here. NSString with format. And once again, we would think that it would be an @ sign and parentheses and then a %D close parentheses and then our answer. But once again, we get a compiler warning. Let's take a look at that. And it's obviously the same warning, so we double click that, it casts it to long, and now we have our string. So the last thing we need to do is write a log statement using our %at, because this is an object to hold our object, and we're good to go here. Let's do an NSlog, and then we'll just do my answer string is, and then we do a %at as I indicated, close parentheses, and our argument this time is answer. And now we're ready to run for the last time. My answer string is 20. So that completes NSInteger. So let's review what we've covered. We've covered converting NS strings to integers and vice versa, converting NS strings to floats and vice versa, converting NS strings to NS integers and vice versa, and we've also converted NS strings to NS numbers and vice versa. And I've also devoted an entire video to working with NSDate and the conversions associated with that, so take a look at that to learn more about that subject. So that being said, we've just about covered, for the most part, the most common conversions you'll need for most applications. So that wraps it up for this video. I hope it's been helpful. Keep your comments coming, and I appreciate the thumbs up if you like what you see. Thanks for watching, and please don't forget to subscribe.